Dear children, today we start chapter 2 Polynomials, class 10 mathematics, chapter 2 Polynomials. In algebra, first unit is number system. In number system, we are having real numbers. Second unit is unit 2 algebra. We say it is algebra. In this one chapter is polynomials. So we are going to cover polynomials now. We are going to start polynomials. Here in the syllabus we are having, మనకు సిలబస్లో ఏముంది అంటే జీరోస్ ఆఫ్ పాలినామియల్ కనుక్కోవాలి. ఏదైనా పాలినామియల్ ఇస్తే జీరోస్ని కనుక్కోవాలి. నెక్స్ట్ రిలేషన్షిప్ బిట్వీన్ జీరోస్ అండ్ కోఎఫిషియెంట్స్ ఆఫ్ క్వాడ్రాటిక్ పాలినామియల్. క్వాడ్రాటిక్ పాలినామియల్ ax² + bx + c ఫామ్లో ఉన్నదాన్ని క్వాడ్రాటిక్ పాలినామియల్ అంటున్నాము. అంటే హైయెస్ట్ పవర్ ఆఫ్ x 2 ఉండాలి. ఇప్పుడు రిలేషన్షిప్ బిట్వీన్ జీరోస్ అండ్ కోఎఫిషియెంట్స్ ఆఫ్ క్వాడ్రాటిక్ పాలినామియల్ కనుక్కోవడం, రిలేషన్షిప్ ఎస్టాబ్లిష్ చేయడము, వాటిని వెరిఫై చేయడము. జీరోస్ అంటే రూట్సే, అంటే సొల్యూషన్స్ ఆఫ్ ద క్వాడ్రాటిక్ ఈక్వేషన్. సో ax² + bx + c ఈక్వల్ టు జీరో ఎప్పుడైతే పెడుతున్నామో దాన్ని క్వాడ్రాటిక్ ఈక్వేషన్ అంటున్నాము. ఈక్వల్ టు జీరో రాయకపోతే సో p ఆఫ్ x పాలినామియల్ ఇన్ x అని అర్థం. p ఆఫ్ x = ax² + bx + c. ఓకే, హియర్ develops a relationship between algebraic and graphical methods of finding the zeros of polynomial. Find the zeros of polynomial graphically and verifying the relation between zeros and coefficients of quadratic polynomial. So first we are having zeros of polynomial. Zeros of polynomial అంటే roots of polynomial అనే, అంటే solutions of equation we have to find. So zeros of polynomial అంటే roots of equation, roots of quadratic equation. We will go to the content now. Next slide. Polynomial. What is polynomial? Polynomial అంటే ఏంటి? A polynomial in variable x is an algebraic expression of the form. So p of x = an x power n plus an minus 1 x power n minus 1 plus and so on plus a1x plus a0. So this is nth degree polynomial. What is the highest power of x here? N. So we say p of x is equal to an x power n plus an minus 1 x power n minus 1 plus and so on plus a1x plus a0, where an coefficient of x power n is an minus 1, this an minus 1 here, x power n minus 1 coefficient, here x coefficient a1 and constant term is a0. So an minus 1 and so on a0 are constants. All these are constants, real numbers. N is a non-negative integer. So what is this n? Non-negative integer. Non-negative integer. So that is n may be any whole number, right? Non-negative integer. So that means it can take n can take 0, 1, 2, 3 and so on. So whole numbers, n can take whole number. That means n is a non-negative integer. An must be not equal to 0. So this x power n coefficient is an not equal to 0. Then only we say the highest power of x is n. So this is nth degree polynomial. We say this is nth degree polynomial. So we will go to the next slide. once you see this is a polynomial in variable x is an algebraic expression of the form p of x equal to, you should be able to say, if I ask what is nth degree polynomial, you should be able to say this form p of x equal to an x power n plus an minus 1 times x power n minus 1 plus and so on plus a1x plus a naught, where a naught and so on an minus 1 an are constants. N is a non-negative integer, an not equal to 0. Okay, we will go to the next slide. Here see, the degree of a polynomial is the highest power of the variable. What is degree? Degree of the polynomial is highest power of the variable x. Here x is the variable. So what is the highest power of x in this polynomial? This is example. One example I am giving for you to say about degree. So what is degree of this polynomial? That is highest power of x. 4 is highest power of x. Here 4 is the highest power of x. So degree is equal to 4. Degree of this polynomial is 4. What is degree of another polynomial? Here highest power of x is 3. Here power of x is 1. Here power of x 1 into x power 0. If nothing is there means 1 into x power 0 is there. That means highest power of x is 3 only here. That's why we say degree of this cubic polynomial, highest power is 3. So we say this is cubic polynomial. Degree is equal to 3. In the syllabus we are having quadratic polynomial. If highest power of x is 2, we say that is quadratic polynomial. We will go to the next slide. So types of polynomials. What are the types of polynomials based on degree? So here p of x equal to ax plus b. This is the polynomial. What is highest power of x here? 1 only. Highest power of x is 1. That means it is a linear polynomial. Linear polynomial. When we say a polynomial is a linear polynomial, if it is having highest power of x is 1, then we say the polynomial is linear polynomial. So what is the degree of the linear polynomial? Degree is equal to 1. Degree is equal to 1. If degree is equal to 1, then we say the polynomial is linear polynomial. What is quadratic polynomial? So degree must be 2. So what is the expression of the quadratic polynomial? What is the standard form of the quadratic polynomial? So p of x equal to ax square plus bx plus c. P of x equal to ax square plus bx plus c. This is the standard form of the quadratic polynomial. So degree is equal to 2. Highest power of x is 2. So we say if degree is 2, then we say the polynomial is quadratic polynomial. What is cubic polynomial? If degree is 3, then we say that polynomial is cubic polynomial. Here p of x equal to ax cube bx square plus cx plus d. What about these coefficients? What is x cube coefficient a? What is x square coefficient b? What is x coefficient c? What is constant term? D. D is a constant term. So where a, b, c, d all are real numbers. So here highest power of x is 3. That's why we say degree equal to 3. Degree of the given polynomial is 3. So this is quadratic polynomial. This is cubic polynomial. This is linear polynomial. Earlier we have seen nth degree polynomial. So if the highest power is n, we say that is nth degree polynomial. If highest power of x is 1, we say that is linear polynomial. If highest power of x in the given polynomial is 2, we say that is quadratic polynomial. If highest power of x is equal to 3, then we say that polynomial is cubic polynomial. We will go to the next slide. So how to find value of a polynomial? value of p of x. P of x means a polynomial in x, polynomial in variable x. Value of p of x at x equal to k. So some x value I am taking, some x value I am taking, x equal to k I am taking. So if I take in place of x, if I take x equal to k, then I will get p of k, polynomial at x equal to k, polynomial value at x equal to k I am getting. So if we substitute x equal to k, if we substitute x equal to k in the polynomial p of x, we obtain the value p of k. Example we are taking, so p of x, this is given polynomial, p of x equal to 2x square plus 3x plus 1. This is given polynomial. So value at x equal to 2, that is p of 2. So in place of x I am taking 2. In place of x what I am taking? 2. So in place of x, k taken here. In place of x I am taking 2. So I am going to get p of 2. If I take x equal to k, I am getting p of k. If I take x equal to 2, I am getting p of 2. So p of 2 is equal to 2 times 2 square plus 3 times 2 plus 1. So p of 2 is equal to, so 2 to 4, 4 to 8, 8 plus 3 to 6, right? So 8 plus 6 plus 1, I am getting 8 plus 6, 14, 14 plus 1, 15. So p of 2 is equal to 15. So if they give the polynomial, and if they ask to find at x equal to 2, so we will write in place of x, we will write 2. So p of 2 we got. If they give and ask, they find, if they give this polynomial and if they ask to find the value at x equal to 3, what you will find? P of 3 you will find at in place of x. In place of x what you are going to take? If they ask to find p of 3, you will find p of 3. In place of x you are going to take x equal to 3. Okay, we will go to the next slide. So definition, here some definition. What is the definition? We see first, a real number k is called 0 of the polynomial p of x if p of k equal to 0. So earlier we learnt how to find p of k. In place of x we are taking k, so we are finding the value of p of x at x equal to k. That means p of k we are getting. If p of k equal to 0, if you get p of k value 0, then k is having a name. What name k is having? 0 of the polynomial p of x, ZERO 0. So p of k equal to 0 implies k is a 0 of the polynomial, we can say. Otherwise we can say k is a root of the polynomial, we can say. Otherwise k is a solution of the quadratic equation p of x equal to 0. That also we can say. So here in this chapter we use, if p of k equal to 0, we say k equal to 0 of the polynomial. Always we call k as 0 of the polynomial p of x. When we call k is 0 of the polynomial, if p of k equal to 0, if p of k equal to number 0, then what is the name this k is having? The k is called as 0, ZERO, 0 of the polynomial. Otherwise we can call root of the polynomial. Okay, this means when we substitute x equal to k in the polynomial, its value becomes 0. Its value becomes number 0. So that means what we say, k is a 0 of the polynomial p of x. K is a 0, ZERO. K is a 0 of the polynomial p of x. Otherwise k is a root of the polynomial p of x. We will go to the next slide. So linear polynomial, already we learnt about the linear polynomial. If degree is 1, highest power of x is 1, we say that is a linear polynomial. So linear polynomial consider the polynomial p of x equal to ax plus b. If k is the 0 of the polynomial, then p of k equal to 0. If you are saying k is a 0 of the polynomial, what it means? If p of k equal to 0, then only we say k is a 0 of the polynomial. So if they give k is 0 of the polynomial, we can take then p of k equal to 0. There implies ak plus b, p of k. In place of x I have taken k. So ak plus b equal to 0. So there implies ak is equal to minus b. So k is equal to minus b by a. What is k value? K value is minus b by a. So minus b by a is 0 of the polynomial. So p of x equal to ax plus b. Then what is the 0 of the linear polynomial ax plus b? By seeing this polynomial itself you can say. So constant, here b is constant. What is x coefficient? X coefficient is a. So we can take 0 is minus b by a. Here already I got k is equal to minus b by a. Minus of constant term by coefficient of x we are taking. So k equal to minus b by a is the 0 of the polynomial. We are going to the next slide. Here, what is the graphical interpretation? To understand the geometrical meaning of zeros, what is the graphical interpretation of zeros? So to understand the geometrical meaning of zeros, we study the graph of the polynomial. The zeros of a polynomial are the points where the graph intersect the x-axis. ఇప్పుడు గ్రాఫ్ని యూజ్ చేసుకొని గ్రాఫ్ గీసి జీరోస్ని ఫైండ్ అవుట్ చేయండి అని అడిగారు అనుకోండి, ఏదైనా ఒక పాలినామిల్ ఇచ్చి గ్రాఫ్ని గీయమంటే మీరు గ్రాఫ్ని డ్రా చేయాలి. గ్రాఫ్ని డ్రా చేసిన తర్వాత మీకు ఇచ్చినటువంటి ఆ పాలినామియల్ కర్వ్ ఏదైతే ఉందో ఆ పాలినామియల్ ఎక్స్ యాక్సిస్ని ఎక్కడైతే ఇంటర్సెక్ట్ చేస్తుందో పాయింట్స్ where the graph intersect the x-axis, the zeros of the polynomial are the points where the graph intersect the x-axis. x-axis పై x-axis ని ఎక్కడైతే x-axis అంటే హారిజాంటల్ యాక్సిస్ ని ఎక్కడైతే మీకు ఇచ్చినటువంటి కర్వ్ కట్ చేస్తుందో లేక ఇంటర్సెక్ట్ చేస్తుందో, then we say that x value is 0 of the polynomial. So what are the zeros of the polynomial? The zeros of the polynomial are the points where the graph intersect the x-axis. We will go to the next slide. Here see, this is the graph given. This is graph of linear polynomial p of x equal to 2x plus 3. So p of x equal to ax plus b, that is linear polynomial. So this is in the form of ax plus b only. So a is x coefficient 2, b is constant term 3. So what is 0 here? By seeing this you should be able to say minus 3 by 2. Minus 3 by 2 will be the 0 of the polynomial, that is minus b by a. Already we proved it. So 2x plus 3 in this polynomial, minus 3 by 2 will be on the x-axis. So this is the linear polynomial. If you draw graph for p of x equal to 2x plus 3, as this is a linear polynomial, always you will get a straight line. So you got here, this is the straight line. So here this is x-axis, horizontal axis, this is vertical axis, this is y-axis. We say this is y-axis and this is x-axis. Here values I have taken, x values I have taken here. So minus 1, 0, 1, 2, 3. Here minus 2, minus 3, minus 4. Here on y-axis taken minus 4. This is a horizontal axis, x-axis. So taken 0 here. So minus 2, minus 4, 2, 4, 6, 8, 10. On y-axis we have taken. So linear polynomial is always a straight line, where this polynomial intersecting the x-axis, it is intersecting this x-axis at point minus 3 by 2 comma 0, minus 3 by 2 comma 0. So on x-axis always y coordinate will be 0, y coordinate always will be 0. So x coordinate here I got minus 3 by 2. So this line, given line y is equal to 2x plus 3, this line intersecting the x-axis at minus 3 by 2 comma 0. So we say minus 3 by 2 is a 0 of the polynomial p of x equal to 2x plus 3. We will go to the next slide. So here the graph is a straight line. Above we got in the above slide we got graph is a straight line. It intersects the x-axis at minus 3 by 2 comma 0. Therefore the 0 of the polynomial p of x equal to 2x plus 3 is x equal to minus 3 by 2. So what is the 0 of the polynomial? X equal to minus 3 by 2 is the 0 of the given polynomial. Go to the next slide. So general form of the quadratic polynomial. A quadratic polynomial is p of x equal to ax square plus bx plus c. This is general form of the quadratic polynomial. Already we discussed about it. So the graph of quadratic polynomial is parabola. Graph of linear polynomial is a straight line always. But here graph of quadratic polynomial. Quadratic means highest power of x is 2. So if highest power of x is 2, then the graph of quadratic polynomial is always parabola. Parabola path you will get. That I will show in the next slide. I will show in the next slide the graph also. Here see parabola path. Parabola path you will see in the yes, this is a parabola. This is parabola open upward. This parabola opens up. This is a parabola. Sometimes the parabola opens down also. That is also parabola. Okay. See here this parabola at how many places it is intersecting the x-axis. So this parabola is intersecting at 2 points. This is one point. At this point intersecting the parabola and x-axis, and this parabola intersecting the x-axis at this point 4 comma 0. Here this point is minus 1 comma 0 and here the point is 4 comma 0. So what are the zeros of this polynomial, this parabola? This is polynomial. Y is equal to x square minus 3x minus 4. So if we draw the graph, this is a graph of given polynomial. This is parabola curve. So this parabola intersecting the x-axis at x equal to minus 1 and this parabola intersecting the x-axis at 4. So minus 1 comma 4 are the zeros of the quadratic polynomial x square minus 3x minus 4. So what we say here, x equal to minus 1 is a 0 of the polynomial, x equal to 4 is also a 0 of the polynomial. So how many zeros of the given quadratic polynomial? 2 zeros. Minus 1 is 1 0, 4 is 1 0. So quadratic polynomial is having how many zeros here? This is 1 0, minus 1 is 1 0, 4 is another 0. We will go to the next slide. So for the quadratic polynomial y is equal to ax square plus bx plus c, value of a. If a is greater than 0, this a coefficient of x square is greater than 0, then parabola opens upward. Already we have seen earlier, parabola opens upward. If a less than 0, that means x square coefficient is negative. So if a is less than 0, then parabola opens downward. So minus x square plus x plus some constant 2. So minus x square means minus 2x square, minus 3x square, minus 4x square, anything negative. If a is negative, then parabola opens downward. A greater than 0 means parabola opens upward. A greater than 0 means parabola opens upward. If you draw the graph, then you will get parabola opens upward for a greater than 0. If a is less than 0, if you draw the graph of this parabola of this quadratic polynomial, you will get parabola curve. That is parabola opens downward. These curves are called parabolas. So here parabola opens upward, that is also parabola. Parabola opens downward, that also we say parabola. These curves are called parabolas. We will go to the next slide. So example 1, in the textbook you are having this example. Example 1. Question, look at the following graphs. Each graph represents y is equal to p of x. So polynomial in x. Y is polynomial in x. Where p of x is a polynomial. Where p of x is a polynomial. For each graph, determine the number of zeros. For each graph, we have to determine the number of zeros. We will go to the next slide. Here see, in your question you are having, this is the first question. This is the first one. So how many times this curve intersecting the x-axis? How many times it is intersecting? Only at one point. Only at one point this curve is intersecting the x-axis. This is x-axis and this is the curve intersecting the x-axis at one point only. So how many zeros this curve is having? How many zeros the given polynomial is having? Only 1 zero. So this is parabola curve. That means it is a quadratic polynomial. How many times this curve is intersecting the x-axis? Can you say how many times it is intersecting? Yes, here one time and here one time. At 2 points, this parabola is intersecting the x-axis. That's why this polynomial is having how many zeros? 2 zeros. So this curve is intersecting at how many points? At this point, at this point, and at this point. So at 3 points, the curve is intersecting the x-axis. So we got 3 zeros. We are having 3 zeros of the polynomial, 3 roots of the polynomial. So this curve is intersecting the x-axis at 3 points. At 3 points. So it is having 3 zeros. How many zeros this curve is having? This is a straight line. This curve is a straight line. So at how many points this straight line is intersecting? At one point. So this one, fourth one is having 1 0. For fifth one, what is the answer? This curve is intersecting the x-axis at one point. So this is touching this curve is touching the x-axis. So repeated root you are having here, repeated root. So only 1 0 you are having, but that 1 0 repeated 0 2 times. So how many zeros it is having? Only 1 0. It is having only 1 0. It is touching the x-axis at one place. So it is having only 1 0. That is a repeated root we say. Here see this graph 1, 2, 3, 4. At 4 places the curve is intersecting. The curve is intersecting at 4 places. At 4 places the curve is intersecting. That's why we say the curve is having how many zeros? The polynomial is having how many zeros? It is having 4 zeros because it is intersecting the x-axis at 4 points. That's why this polynomial is having 4 zeros. We will go to the next slide. Here solution, you can see the zeros of the polynomial are the x coordinates of the points where the graph intersect the x-axis. So the zeros of the polynomial are the x coordinates of the points where the graph intersect the x-axis. So in graph 1, the curve is intersected the x-axis at one point. In graph 2, the graph intersecting the x-axis at 2 points. So 2 zeros it is having. In graph 3, it is intersecting the x-axis at 3 points. So it is having 3 zeros. Fourth one, that curve is having only 1 zero. Fifth one, the curve also intersecting the x-axis at 1 point. So it is also having 1 0. Last one, it is intersecting the x-axis at 4 points. So it is having 4 zeros. The graph is having that curve. That curve is intersecting the x-axis at 4 points. That's why it is having 4 zeros. We will go to the next slide. So here explanation, the number of zeros of a polynomial is equal to the number of points where the graph cuts the x-axis. ఇచ్చినటువంటి గ్రాఫ్ x-axisని ఎన్నిసార్లు అయితే కట్ చేస్తుందో అన్ని జీరోస్ ఉన్నట్టు చెప్తున్నాము. ఇఫ్ ద గ్రాఫ్ ఇంటర్సెక్ట్ ద x-axis వన్స్, x-axisని ఒక్కసారే గనక కట్ చేసినట్లయితే, ఒక్కసారి ఇంటర్సెక్ట్ చేసినట్లయితే ద పాలినామియల్ హ్యాస్ 1 0. ఇఫ్ ద గ్రాఫ్ ఇంటర్సెక్ట్ ద x-axis ట్వైస్, x-axisని 2 సార్లు ఇంటర్సెక్ట్ చేసినట్లయితే ద పాలినామియల్ హ్యాస్ 2 zeros. పాలినామియల్కి ఎన్ని జీరోస్ ఉంటాయి? 2 zeros ఉంటాయి. ఎప్పుడు? ఇఫ్ ద గ్రాఫ్ ఇంటర్సెక్ట్ ద x-axis ట్వైస్, ట్వైస్ మీన్స్ 2 times, the polynomial has 2 zeros. If the graph intersects the x-axis 3 times, the polynomial has 3 zeros. Important result, a polynomial of degree n, a polynomial of degree n can have at most n zeros. సో ఏదైనా పాలినామియల్ nth డిగ్రీ పాలినామియల్ అని చెప్తే, nth డిగ్రీ పాలినామియల్ తీసుకుంటే దానికి మ్యాక్సిమం నెంబర్ ఆఫ్ జీరోస్ ఎన్ని ఉండొచ్చు అంటే n ఉండొచ్చు. n కంటే ఎక్కువ నెంబర్ ఆఫ్ జీరోస్ ఉండవు. n కానీ n కంటే తక్కువ కానీ ఉంటాయి జీరోస్ వచ్చేసి. సో ఇప్పుడు క్వాడ్రాటిక్ పాలినామియల్ తీసుకోండి. క్వాడ్రాటిక్ పాలినామియల్లో హైయెస్ట్ పవర్ ఆఫ్ x ఎంత? 2 కదా. ఓకే, సో ఆ క్వాడ్రాటిక్ పాలినామియల్కి మ్యాక్సిమం ఎన్ని జీరోస్ ఉండొచ్చు? మ్యాక్సిమం 2 zeros ఉంటాయి. 2 కానీ అంతకంటే తక్కువ కానీ ఉండాలి. 2 కంటే ఎక్కువ మాత్రం ఉండవు. సో దిస్ ఈజ్ ఇంపార్టెంట్ రిజల్ట్. ఏ పాలినామియల్ ఆఫ్ డిగ్రీ n కెన్ హ్యావ్ ఎట్ మోస్ట్ n zeros. విల్ గో టు ద నెక్స్ట్ స్లైడ్. సో క్వశ్చన్ 1 in exercise 2.1, question 1. The graph y is equal to p of x are given in the figure for some polynomials of p of x. For each graph, find the number of zeros of p of x. Hint, the number of zeros of polynomial is equal to the number of points the graph intersect the x-axis. x-axisని ఎన్నిసార్లు ఇంటర్సెక్ట్ చేసిందో మనకిచ్చినటువంటి గ్రాఫ్, దాన్ని బట్టి నంబర్ ఆఫ్ జీరోస్ ఎన్నో చెప్తాము. Go to the next slide. Here see, these are the graphs given in the question. In the first one, how many times it is intersecting the x-axis? It is not intersecting the x-axis. It is parallel to, this is x-axis and this is the line. This is not intersecting the x-axis. It is parallel. It is not intersecting. So there is no zero of p of x. So p of x is not having any zero, any root. P of x is not having zero here in this case. Now coming to second graph, how many times this curve is intersecting the x-axis? Only one time. So this one, second one is having 1 0. How many times this curve is intersecting the x-axis? Tell me. One time. This is second time. This is third time. So 3 points. At 3 points, the curve is intersecting the x-axis. So how many zeros it is having? 3 zeros it is having. Now coming to fourth graph, this is parabola. So quadratic polynomial. How many times this quadratic polynomial or this parabola intersecting the x-axis? At 2 points. So how many zeros it is having? 2 zeros it is having. Now look at graph 5. How many times the given curve intersecting the x-axis? 1, 2, 3, 4. So the graph intersecting the x-axis at 4 points. So how many zeros it is having? 4 zeros it is having. Now coming to the next one. How many times the given curve intersecting the x-axis? 1, 2, 3. At 3 points the given curve intersecting the x-axis. That's why how many zeros the given curve is having? 3 zeros. Go to the next slide. Solution. The same thing here. Number of zeros we have written. So relationship between zeros and coefficients. Zeros. How many times the graph intersecting the x-axis? So that many zeros the curve is having, the polynomial is having. Now what we are going to establish? We are going to establish relationship between zeros and coefficients. Coefficients means what is x square coefficient? A. What is x coefficient? B. What is constant term? C. So here coefficients are A, B, C. We say A, B, C are coefficients. X is variable. So for the quadratic polynomial p of x equal to ax square plus bx plus c, if alpha and beta are zeros, then quantity. So sum of zeros, alpha plus beta. Alpha and beta are, if alpha and beta are zeros of this polynomial, then sum of zeros formula alpha plus beta, product of zeros formula alpha beta. Here derivation to find alpha plus beta, we are having the derivation here. If alpha and beta are the zeros of p of x equal to ax square plus bx plus c, then p of x equal to, so we can write if alpha and beta are zeros means x minus alpha is a factor of p of x and x minus beta is also factor of p of x. What is x square coefficient? A. So we can write p of x is equal to a times x minus alpha times x minus beta. Now expanding this, so a times, if we multiply these two factors, what we are getting? X square minus of alpha plus beta times x plus alpha beta. So ax square minus of a times alpha plus beta times x plus a times alpha beta. Go to the next slide. Comparing ax square plus bx plus c with this expanded form, ax square minus a times alpha plus beta times x plus a alpha beta. If we compare these two, what are the x square coefficients? X square coefficient here also a, here also a. What is x coefficient here? X coefficient is b. So here minus a times alpha plus beta. So I can take b is equal to minus a times alpha plus beta. As x coefficient is b, here also as x coefficient is minus a times alpha plus beta, I can write, after comparison I can write minus a times alpha plus beta is equal to b. What about the constant here? C. Here a into alpha beta. So a into alpha beta equal to c. So alpha beta I can find by using this. alpha beta is equal to C by A. So same thing here I have written alpha plus beta is equal to minus B by A, alpha beta equal to C by A. Go to the next slide.